say now we have to find the moment of inertia of a cylinder. Obviously, we are not saying this is a thin rod. We are saying this is a solid cylinder of mass m, length L and radius r. We have to find its moment of inertia about this axis which is passing through one of its ends and perpendicular to its length. Now here we shall be making use of one thing, that is time and again, probably here also, in a right circular cone also, in hemisphere also, so many times we shall be using it. That is, what is moment of inertia of this disc number 1 about this diameter. We know about this diameter, if this is I, about this diameter is also I. And we know the moment of inertia about this central axis, we know that is mr square by 2. So mr square by 2, if we use perpendicular theorem, so I plus I is going to about I z z dash, I x x dash plus I y y dash is equal to I z z dash. So I plus I, 2I is equal to mr square by 2. So I, that is about a diameter, is going to be mr square by 4. So this is one result we shall be using time and again. So if we take this, we are looking from a side, and so about moment of inertia about of this disc of mass m and radius r, about this is mr square by 4. If we have to find the moment of inertia about any other axis which is parallel to this axis, so obviously this axis is passing through the center of mass, so we can use the parallax theorem, and if this distance is x, then I y dash about this axis is going to be ICM plus m into x square, where m is the mass of this disc. So it is going to be mr square by 2 of this plus m into x square. We shall be using this concept over here also. In this case also, we shall be using this concept to find the moment of inertia of a right circular solid cone or a hemisphere also, and in a number of cases this concept is used. Let's see how do we use that. So obviously this total mass is m and it is uniformly distributed over the length L. So the mass per unit length is m by L. So this is what? Mass per unit length. So this is mass per unit length. So what I do is, at a distance x, I take a small section. So at a distance x, what I've done is, I've cut a small section, that is I've taken out a small piece of this disc. I've taken out. So this is a disc which I have taken out. This is a small disc I'm considering at a distance x over here. So obviously its thickness is almost equal to 0, that is dx. So this is a disc. So what is the mass of this disc is? Total mass upon total length into dx. That is mass per length, and if the thickness is dx of any section, its mass is going to be m by L into dx. So this is going to be dm. So this is a differential element of mass of this disc. If the mass of this cylinder is 20 kg and suppose the length is 10 meter, so for every 1 meter it is 2 kg, that is 2 kg per meter is the mass of mass per unit length for this cylinder. If the disc is of thickness, let's say 3 meter, so once again it comes out to be 6 kg. If it is dx meter, so we'll say 2 kg per meter into dx meter, we'll get it 2 into dx. Similarly over here, if the total mass is m and distributed over a length L, this is uniformly mass distributed, so it is m by L is mass per length, and of this thickness m by L dx. So mass of this disc is m by L dx. We have found the moment of inertia of this general disc which we have taken at distance x from this axis from about which we have to find the moment of inertia. Now let's say, can we somehow correlate this disc with this what we have understood? The moment of inertia of this disc about this axis is passing through its center of mass, or from this center of mass. We don't have to consider the center of mass of this whole rod. It is, we intend to use parallax theorem between this disc and this axis. So this axis is passing through this disc, generalized disc, and this is ICM of this disc about this axis is what? mr square by, we have found this about diameter, it was mr square by 4. So it is going to be, that is dm, that is m by L dx into r square. R of this is r only, that is r is same throughout this. Whether you take disc over here, you take disc over here, r is the same, that of cylinder, that is r is same, m into r square by 4. So this is moment of inertia of this generalized disk about this, but we have to find the moment of inertia about this axis. So this is what? This is going to be ICM plus m into x square. What is that? That comes out to be m by L dx into r square by 4 plus m of this disk only. What is that? That is m by L dx m into x square. This is going to be moment of inertia of this disk about this axis only. Moment of inertia of this whole cylinder, solid cylinder, about this axis is moment of inertia of this first disk about this axis plus this disk about this axis plus this disk about this axis plus. That is, we integrate it. First disk is what? At a distance of x is equal to 0. And where is the last disk? It is at a distance of x is equal to L. So moment of inertia of this whole cylinder about this axis Iyy dash is integral of this whole term. So when you integrate it, it comes out to be ml square by 3 plus m into r square by 4. A simple integration, you can get the answer.